Okay, so now we're going to do more examples on shear. We're going to continue with example 9.2. 9.2, what it will show you is the use of a table for selecting the spacing of the stirrups, and then also will show you how to plot the shear strength that you are providing based on your design. Okay? On example 9.1, what we did is we found a spacing for shear, but it was simple. I mean, there was no other choice. You only have one choice, and so you had to use that value. Here, we're going to have now to decide what spacing to use based on the table that you obtain. So 9.2 then is very similar to the one we just did. I just adding additional load, so you will have more shear requirement, and it had to be done that way. So 22 feet is the length. The load has been increased. You got a 0.9 now, also, and then your concrete and your yield value. Everything is the same, 17 inches, 12, 20. Okay? So we find the bin weight, we find our load combination. Load now is pretty high. This is your shear. This is the reaction, right? So this is what you find here, the reaction. So now we need to find this at the distance D. So we move the value to the distance D by subtracting the load times D. Right? And maybe here I should do, yes, to make sure I do this. Well, okay, reaction. So this is going to be really your reaction, right? So reaction at A, this would be the left support, right? Reaction at A minus your WU, so it's going to be your load, right? So you're going to have your WU multiplied by 17 inches, so that's your D, right? And that's really what we need. So let's do that. WUD, okay? And that equals. So that's really all you need to find your value. This is your reaction at the left support, right? And so we have the reaction, then WU, and this is your D value changing to feet. Okay, and so that gives my value then at the distance D. And of course, this is your A value. This is your support A, and this is your support B. Okay. All right, I'm going to find my stirrups using the first formula in the equations from the ACI, and remember you had to satisfy AV minimum to use these formulas. So here is the formula, and find my phi sub c. Just replace the numbers. My lambda is 1, my phi factor 0.75, my f prime c was given in the problem, right? 4,000. My BW12, D17. So we use those numbers and we get 19.4. Find V sub C without the phi factor. That would be 25.8. And then you find this limit that we need to have. Since we are using the 2 formula, that limit happens to be the same value divided by 2. So we got 9.7. Okay? 19.4, 9.7. Now our VU is a lot bigger than this number, so we definitely need the stirrups. Okay. Now how far do we need the stirrups? We can use proportions to find that. Right? I show you that. So what we can do is in the proportions we can do 63.8, right, is proportional to 132. So that's the big triangle here, right? as 9.7, which is that one, is proportional to z. And so you're going to find z, and then you subtract 132 minus z, right? You subtract z from 132, and that gives you the distance that you need to cover stirrups, which is from here all the way to this point. Okay? You need stirrups. Okay? And so we're going to do that first by proportions, as I said. Okay? That 112. You can use the same thing using your formulas for mechanics of solids, right? Reaction at A minus WUX, right? And X in this case is this value X, so it's moving from left to right. So I want to know the value of X when this shear equals 9.7. So I'm going to make my VU equals 9.7, right? My reaction, my omega U, and my X, and I got 9.33 feet, change it to inches, I get about 112, very similar to that number. So 112 then, so 112 right here, color-coded, right, is the distance that I need to cover with the stirrups. Okay, next I'm going to find my V sub S, right? So I take my VU at the face and I subtract the contribution of the concrete, and that will give me what I need to cover with the shear reinforcement. So I get my value. Now in the formulas you're going to need a lot of times to use VS and not phi V sub S. So we're going to find VS by dividing phi V sub S by phi, and so that gives me 48.3. Okay? So I got phi V sub S and I got V sub S. Yeah? All right. So next I'm going to find the stirrups that I need, or the spacing of stirrups that I need to carry this shear. Okay, this is the shear I'm designing for. Okay? So for that value of shear, I'm going to find my two limits, right? And they're here. And my VU, in this case, VU at D, okay, is 48.3 and is below the 51.7. Right? Below the 51.7. Oh, wait a minute. No, excuse me. My V sub S, right? My V sub S, 48.3, is below these numbers, so we are good. Okay? We are good. Notice that you would not have done this, right? You would have not used VU and D, but you would use 63.8. That would have put you over this value, and then your design would have been a lot more conservative. Okay? So it's not just designing to design, you also have to look for the economical solution. No? All right, so for this case then, my spacing is limited to S maximum, which is D over 2 or 24. So D over 2 governs, and that's 8.5. So far it's the same as the previous problem, right? We're getting a maximum spacing of 8.5. Now this diagram, right, is going down. So eventually it's going to get to this point right here where it's below this number, which is your phi V sub C. Then at that moment I can change my spacing to the minimum requirements and to the D over 2 and 24, right? And so we're going to check those values. So this is the same. This is the minimums. Okay, 22 is the minimum, and that controls. Okay, in there. Okay, but out of the 4, you have to pick 8.5. So that means that 8.5 is the maximum that you can use from this point all the way to 9.7. Okay. Spacing across, that's easy. That's again 17 inches, which is your D. You have 12 inches only width, definitely satisfied. So, all right. Next, I need to find me my S. And where is my S? Oh, that's missing. So that is missing. So right here, I don't know what happened. So it's supposed to be here. Okay, so let me delete that. Let me go here. I don't need that. And let's copy this one. Right? Copy. Okay. So this is my S required. Okay. S required. At D, right? Because we're doing the shear at D. Okay. So this is my S required at a distance D. So that's what we're trying to find. So it's going to be my AV. Okay, that's good. My 60, which is this one. My D doesn't change, but my V sub S is now 48.3. Right? So this value is 48.3. And so now my spacing is 0.22 then. 0.22 times 60 times 17 divided by 48.3, that's equal to 4.6. Okay, so this value now is 4.6 inches. So that's what is required to carry that shear at the distance D. Right? That's the 4.6. So we're going to round it down to 4. Okay. All right, so that means that we're going to start from the face, right? From here, from the face, we're going to start 1 at 2 or 1 at 3. Then we start using spacings at 4 inches. Okay? So the question is, when could I stop using a spacing of 4 inches? So I can switch to something else. Okay? Remember the maximum spacing is 8.5, which we rounded down to 8. So in this case, the table is not that complicated. It's pretty simple. Only has 4, 6, 8. You can use 7 and 7 and 7. That's it, right? Or 5, right? 5 and 7 if you want. But I mean, 4, 6, 8. Those are good values. So we find what is the V sub S. So this is your formula for V sub S. We just used it here, right? But now this is the generic formula. Okay, I'm going to solve for V sub S, right? And I'm going to put the S back here, but this is now any S, so it's not the required at D, it's just S at different places, all right? So what I'm going to do is I'm going to leave this formula as a function of S. Okay? So as a function of S, then it will tell me how much this number is. So if I do a spacing at 4 inches, my strength provided by the stirrups is 42.1 cubes. If I provide the stirrups at 6 inches, my V sub S is 28.1. If I provide the stirrups at 8 inches, my strength of just the stirrups is 21. Okay? So this gives me then the strength provided by the stirrups, just the stirrups. Then to have my total shear strength, I need to add to these the concrete strength, right? But the concrete strength for our case is fixed, right? Is one number, and that number is 19.4. So concrete strength 19.4. So we're going to add to all these numbers 19.4. So 42.1 plus 19.4 gives me that. Right? 28.1 plus 19.4 gives me this. 21 give me this. And we have to maintain VU less or equal than these numbers. Okay? So what this means, is that I have to use the spacing of 4 inches until my shear is at least 61, or is, yeah, it's at least 61.5. Okay? If I can get it lower, even better. Okay? But if it's higher, I cannot change to 4. I cannot use anything less than 4. So a spacing of 4 has to be used all the way till the shear equals 16.1. Yeah. I can change to 6 the moment I can have at least 47.5. I can change to 8 when the shear equals 40.4. Because remember, you have to keep VU, so these values are V sub n's, phi V sub n's, okay? These are design strengths. So you want your VU to be less than this. You want your VU to be less than that. So that means I can use 6 inches unless my VU is less than this number. Otherwise, I will be exceeding that value. So how do I find the distance for this? So let me see, I think I changed the variables. Let me see if I did that. Yeah, I changed it, X. So I did switch the values. So this is supposed to be now X. All right, so we're going to use our mechanics of solids equations, right? Reaction minus WUX. And we're going to find the distance from the support to where I can make the change, right? So where is 61.5 happening? It happens at 4.8 feet. Oh, no, sorry, this is in inches. So happens at 4.8 inches. Okay. The value for 6 inches happens at 33.7 inches. And the value where I can switch to 8 inches happens at 48.4. Okay. So what we're going to do, since we have to use the 4, we're going to say, okay, I need to use the 4 until I can switch. I want to switch to 8. You just pick one value. Okay. Remember, you had the option of 3 values, right? Normally 2, you can do 2 as good. You have to do 3 when you do 3, but 2 probably is good. So I'm going to go from 4 to 8. So when could I switch to 8? When my shear is either equal or less than 40.4. And that happens at 48.4 inches. Okay. So I need to provide then stirrups at 4 until I go past this number. Okay. So that means I need to provide at least 12 of these, 12 stirrups at 4, right? That will be 48. And then if I provide one at 2 inches, I'm close, right? 48.2. Right? So I may need more in order to do that. Okay. So what I did here then is 1 at 2, 12 at 4. So that gives me 48.2, close, okay, compared to what I need. And then I'm going to add 8 more at 8 inches to cover the rest all the way to where the stirrups are needed. We need the stirrups to 112. By adding 8 at 8, we get covered now 114. So we went a little bit past that number, right? Now we have. So So then the 12 at 4 will be 48 inches plus 2 inches, that will be 50 inches. So we got a total of 50 inches, so that is past this number, so now I can switch to 8 inches. Okay. So we switch to 8 inches right there. So what is the idea? You have to start with this one because that's what you found here. Okay? So you have to start with that one. The 1 and 2 doesn't count. You always have to use that one. 1 and 2, 1 and 3. Okay? But then the question is, how many stirrups do I need at 4 inches to switch to, say, 8? You pick the next number. It's your choice. Okay? So how many do I need? Well, I need enough stirrups at 4 so that I will cover at least this distance. So 12 stirrups at 4 will give me 48 inches, plus the 2 inches of the first one, 1 and 2, will give me 50 inches. So that means I already went past this number. I can switch now to 8 inches. Okay. How many do I need to use at 8 inches to cover all the way to the length I needed for stirrups, which is the 112, right? Well, in this case, I need 8 at 8. That will give me 114, which is more than 112, and then I'm satisfying my requirement. So what you have done, for a distance of 50 inches, so from here to here, you are providing 61.5. 61.5, because that's what you're providing, right? At that moment, when you reach the 50 inches, you drop and you go to number 8 at 8. Now you're providing 40.4. So at that moment you drop, you're now providing 40.4. To what point? Until you get to the stirrups, right? Length of stirrups. And at that moment you don't need stirrups, so you're providing only the concrete. 19.4. Okay? 19.4. Remember, 19.4 is your concrete. Okay? So right there, right? So that's what you're providing. Okay? All right. So that's pretty much the design. However, there is a section from here to here, right, that may change this value if you do not provide AV minimum. Remember, this value is based on the fact that you are going to use AV minimum. So I need to make sure that I'm providing here AV minimum. So this is, we have gotten all the way to 114, right? So we have covered 114. But to go all the way to the center, it will be 132. So that's a total of 18 inches. So how many stirrups do I need to put between this point, which is 114, and 132, so AV minimum is satisfied? There is only 18 inches here. Well, the AV minimum spacing is referring to these two. So this one is 22. Well, you only got 18 inches. So you're going to put right one at the end, right at the center. Okay? So right at the center of the beam, you provide 1, and that spacing is 18 inches. So it's less than 22. You satisfied AV minimum, and therefore, the value that you found using the equation for V sub C is correct. All right? So we have that. All right, so here, I think I'm going to do something. Do that, and I'm going to insert a paper. Okay, so that way this one goes here, and then we bring that AV minimum. What is that AV minimum? So that's my AV minimum I need to satisfy. And Uh-oh. I messed it up. So, okay, I'll fix it before posting. All right. So next thing we need to do is problem 9.3. 9.3, what it's going to have is it has it has a drop on the shear diagram, and that's what it makes it different. Okay, it's a little drop here. So what happens, right? How do you deal with that drop? And I didn't give you the loads, I just gave you the shears. Okay, so the value VU here 1 is this much, VU2 is that, VU3 is 45. Okay, BW is 14 inches, D is 20. So the first value is given at D from the face of the support. So that's kind of your first design value, right? VU at D. And then you have a value 60 and a value at 45. Okay. So VU at D equals to VU1, which is 75. Again, you're going to assume that you're going to provide minimum amount of stirrups. Therefore, you will use the first, either of the two equations from ACI, the first two. We are going to use everything will be based with this one. We're going to ignore the other equation, all right? And that means we got then a phi v sub c of 26.6. This value happens to be half of that, so that's 13.3, right? BU at D, which is 75, is way bigger than that. So now we need to find the length that needs to be covered by stirrups. Again, you can do that by proportions, but now what proportions do I use, right? That's what the diagram wants to show you. So what do you do now with the proportion? Remember, before we did this value, right, divided by the total length, right, to do the proportions. But now we can't. So now we're going to do this value, okay, divided by this length, which is 10 feet minus 4 feet 9 inches, this value. So 45 divided by this value, proportional to this number, right, over the z, right? And so that's what this one is. So as you can see here. Okay? So 525 is the distance from here to the end, and this number here is 13.3, right, which we found, right? And so we solve for z is 1.6. So this is 1.6. So that means I need to cover my stirrup, I need to cover 8.4 feet, which is 100.8, I would say 101 inches. Okay, mean, that's what I need to cover. All right. So you find your V sub S, it will be VU minus phi V sub C. And then you divide by the phi factor to get only V sub S, so you get your values. Right? Then find the ranges. So we got 78, 141. We're still below 4. So that means D over 2 and 24 control your values, right? And again, this is dropping, right? It's going down, 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 down. So eventually you're going to get to the value where it is the minimums, right? And so for that, we had to use these 4 values. Still, this one controls. Minimum, though, is controlled by 18.9. Okay, so spacing across the beam width, D is 20. And so the width is less than that, so 14 inches, so that's satisfied. Okay. Good. So we get here now, and what we found then is that from the face all the way to the point where is this 13.3, right? We can only use a value of S of 10 inches. We cannot exceed a spacing of 10 inches between the face and the value of 13.3, which is this number here. Okay. So remember, you have to cover all the way to that number, which is now, right? So that's what we have. All right. So now, next we're going to find the requirement for the spacing for this maximum shear that we found, this VU1, right? So that's only for VU1, so it starts right in here, okay? So we find the formula, there it is. It gives me again 4.1, we run it down to 4. Okay? Now we're going to create a table. Maybe, but let's see. The last column in the table is not needed because most of the values for V sub n are located at the drop in the shear diagram, right? Therefore, in order to switch from 4 inches to 6 inches or to 7 inches or to 9 inches or 10 inches, because this is the maximum I can use, remember? I cannot go past that number. It is necessary to cover or to put stirrups all the way to the drop. Right? All the way past the drop. So that means I need to cover at least 4 feet 9 inches, which is 57, using what spacing? Using this spacing. Okay? This spacing right here. Okay? So that's the one I will need to use. Okay? So in order to satisfy that requirement. Okay? Anything else will not work. Okay? Will not work. So you go here, I mean, this is the table. See, I create my table. 4, 5, 6, 7, 8, 9, 10. Okay, put all of these values this time. Okay. For each of the values, I find my V sub s as a function of s first. I find the formula. And then I put the s, I replace the s. So this gives me the strength from the reinforcement. I add to this one the strength from the concrete, and I get my values. Notice that the lowest value we have is 46.4, right? Okay. How much is VU at 2 and how much is VU at 3? Well, VU at 2 is 60 and VU at 3 is 45, right? So if this is 60 and having 46, right? I gonna do it, right? And then this value is 45, and I'm still here, right? I'm still looking at 46 kips. So I cannot do it either, right? So I need to go then lower than that, and so we can start changing right there, because this is 45 with 46. So right in here we start making the change. So I need to go past the drop in order to actually change to a new spacing. And at that moment I can pick any of these values, because all these numbers, right, all these numbers, all of them, 76 all the way to 46, fall in here. Okay? They're all in here. Okay? Because this is 60, this is 45, they're all in here. So that means that I can pick any of the number that is convenient for me, because all are here, as long as I do that. Okay? All right. So what do I decided, well, one possibility is 1 and 2. You always do that, right? Remember, 1 and 2, or 1 and 3. You have to do that. I'm going to do 15 and 4. That's 60. So now I got 60 plus 2, 62. And I needed to cover 57 inches. So I passed that. So now I pass the drop. I'm someplace around here, which is below the numbers that I got. So I can switch to any spacing I want. Okay? I decided to go from 4 to 10. That's my next spacing. If I add 4 and 10, that's 40 inches, gives me 102. The minimum I needed to cover is, how much? 101. right? That's the minimum I needed to cover, 101. Okay. And the spacing cannot exceed 10 inches, right? Now notice that I'm changing this uppercase S to lowercase s, because that's how the code now has it, all lower cases in there for spacings. All right. So this one satisfies that because I went past the 101. Or I can do 1 at 2, 14 at 4. That gives me 58, right? And 58 is more than 57, so we pass the drop again. So that means I can pick now any shear I want, okay? Because all the shears to the right of the drop are below these numbers, so I can use them, okay? I'm going to use 6 at 8, right? So 4, 8. So that gives me 106, okay? This is a much better choice because you're going 2, 4, 8, right? In the field, the guy knows, oh, I'm going to start with 2, then I'm going to double, and then I take that spacing, I'm going to double it, right? So they can kind of match that pretty easy. Mm-hmm. How do you plot your strength provided? Well, this one doesn't count. This one right here, the force. The force, spacing at 4, provide a strength of 76.1. So 76.1. Where do you change it? Right at the drop. You're passing the drop by a little bit, and then you're changing. Changing to what? You're changing to spacing of 8. How much is the strength of 8? 51.4. So you're dropping, and now you're providing 51.4, right? And then after that, you're going to drop and use only the concrete, which is 26.6. Okay. So that's the graph of the strength provided, right? And a table to select your values. Right? Now, we still got the problem of the part that is here that we haven't designed, right? Okay. So we covered so far with this guy 106, but we need to get, we need to cover the rest of the dimension, right? Okay. So what I'm going to do is add one more stirrup at the center, right? So that way I don't have to use a new formula, the third formula from ACI. And since we need only 14 inches to get to the center, right? That value is way below the 22 that is controlling the minimum numbers, right? So minimum numbers, oops, doesn't look like 22 here. Minimum value is 19. Okay, so it's 19, that's your minimum value. Oh, 22 was the previous problem. Okay, so 19 is the minimum value, and you have, make sure that we get that. So this right here is 120, right, to the center. 120 inches. We already used 106, so that means I need to cover 14 inches, and that is satisfied because this value happens to be 19 inches, right? So perfect. Right? It's below 19, we satisfy me. Okay. All right, so I'm going to stop here. That shows you two tables, and one simple table, a more complex table, and how to plot the shear strength that you are finding.